Hello learners, welcome to Naga courses. In today's class number 6, part A, we are going to cover one small example problem on Gaussian random variables, followed by some other useful distribution and density functions. Here, regarding this problem, obtain the values of Gaussian distribution function at x is equal to x plus sigma x and at x is equal to ax minus sigma x. What is the relation between a normal distribution function and normalized distribution function? It is the normal distribution function. It is the normalized distribution function. Fx of x is equal to f of x minus ax by sigma x. Let substitute this first condition here at x is equal to ax plus sigma x. What is this equation now becomes? Fx of ax plus sigma x is equal to f of ax plus sigma x minus ax by sigma x. Ax will be gets cancelled. Left over with f of 1. F of 1. Okay, f of 1 value is given like 0.841, which is given in appendix B of People's textbook. It is will be given in the back side of People's textbook. Okay, I will show you just the front title page of the People's textbook. It is very important application point of view for easy reference. Okay. The book title name is Probability, Random Variables and Random Signal Process by Patent Peoples, Tata McGraw edition. Okay, in this book we can get this appendix B where you can get this value directly as 0.841. Okay, next at x is equal to ax minus sigma x. Then what is after substitution? Fx of ax minus sigma x is equal to f of ax minus sigma x minus ax by sigma x. What is leads to f of minus sigma x by sigma x is equal to f of minus 1. What is the relation between f of minus x and f of x? F of minus x is equal to 1 minus f of x. Hence it can be written as 1 minus f of 1. What is f of 1 value? Substituting this value here, what we get in 1 minus 0.841 is equal to 0.159. Okay. This is how we get this values of the Gaussian distribution function at x is equal to ax plus sigma x and x is equal to ax minus sigma x. Okay. Next we move on to the other useful distribution and density functions. Other useful distribution and density functions. Okay. First one is binomial function. Second one, Poisson. Third one, uniform. Fourth one, exponential. Fifth one, Rayleigh. Okay. Here we have 5 different forms of distributions and density functions. One is binomial, Poisson, uniform, exponential, Rayleigh. Okay. Now let us start with this binomial function. Okay. Binomial function here. A. Binomial. For binomial function, given a random variable x. Here we are dealing with only single random variable only in this context. Okay, for single random variable x, how the density function is described by density function of the binomial density function described by fx of x is equal to algebraic summation k is equal to 0 to n nck p power k 1 minus p whole power n minus k into del of x minus k. Okay, here what is distribution function? Distribution function is given in the same form except that del is replaced by u. Fx of x is equal to algebraic summation k is equal to 0 to n nck p power k 1 minus p whole power n minus k into u of x minus k. Okay, what is this p here? Okay, what is this p? We continue. Where p is lying between 0 and 1. The range of p is between 0 and 1. Okay, this is binomial density function. Lies between, that is p value lies between 0 and 1. Okay, here what is this possible values of n here? N is equal to 1, 2, dot dot dot. Okay, likewise depending on the case of the problem where we take a number of sample points. Okay, next where to find this application? Application, I'm writing in short form. APP stands for application. Application is detection problems in radar and sonar. Detection problems in radar and sonar, we make use of this, as well as it is also used in experiments consisting two outcomes for a given trial. That is why the name is given binomial. Bi stands for two. Okay, it is the application area of the binomial density function. Let us start with some small example problem and have sketch. Okay, example. Plot binomial distribution and density function for p is equal to 0.25 and n is equal to 2. Okay, we need to plot the distribution density function for a binomial random variable. Okay, let me write this with this first equation fx of x. Okay, already it is being written here. I need not repeat. Fx of x is equal to algebraic summation k is equal to 0 to n nck, it is called as nck. Okay, missed here what is this nck representation earlier. Let me write here. nck stands for binomial quotient. I am representing here. Note nck is equal to n factorial by k factorial into n minus k factorial. Okay, first try to obtain the binomial quotients for three different possible conditions here, because k is varying from here. What is the range of values of k? K is equal to 0, 1, 2, because n value is given as 2. K possible values are 0, 1, 2. Okay, correspondingly we get the amplitudes. Amplitude for k is equal to 0. What is the amplitude for this amplitude in this sense? nck p power k 1 minus p whole power n minus k. Okay, I am going with direct substitution. You can check as a tutorial problem. Okay, these values I am directly entering here. What is this first amplitude for for k is equal to 0. For k is equal to 0, what is the amplitude is given by here? Amplitude is given by 0.5625. For k is equal to 1, amplitude is given by 0.375. For k is equal to 2, the amplitude is given by 0.0625. With these values, we need to sketch distribution density function. First, let me obtain with this density function, then you can project onto the distribution function. Okay, it is the density function. Okay, so for example, it is the origin. At origin, we find how much height, amplitude 0.5625. Okay, this is the origin. What is the amplitude at x is equal to 1? 0.375. What is the amplitude at it is 1? What is the amplitude at 1, 2? Simplifying, it is 0.0625. Observe here, these are density function with 3 impulses. One is occurring at x is equal to 0 with amplitude 0.5625. The other one is at x is equal to with amplitude 0.375. The other one is at with amplitude 0.0625. If you were to project these on, how do you get this distribution function? Distribution function, say for example 0, it is x, means it is fx of x. Let us take this one as 0.5, okay. So for example, it is at 1. The first graph up to here, it is how much amplitude? 0.5625. When at x is equal to 1, this amplitude will be added to the next amplitude, that is 0.375. Then what is the amplitude we will be getting? Cumulatively we will be getting 0.9375. Then at 2, for this 0.9375, cumulatively we have to add 0.0625. Finally, we will be getting 1. This amplitude is 1. It is 1. That means it is this plot is dispersion function. This plot is density function for the given binomial random variable with n is equal to 2 and k is equal to p is equal to 0.25. Let me go with quick revision here. First exam problem where we obtain the different values at x is equal to ax plus sigma x, x is equal to ax minus sigma x, and these values are being obtained from the appendix B of the pupils textbook. Okay, next one is binomial. We have 5 different distribution functions: binomial, and Poisson, uniform, exponential, and Rayleigh. And binomial density function. Density function is given like this here. Next one is distribution function. Application area is it is widely used in detection problem in radar and sonar. It is also applied in experiments containing 2 distinct outcomes for a given trial. Next we move on to some simple example problem where with P is equal to 0.25 and N is equal to 2. We get 3 sample points already drawn in the form of B. B is the density function and A is the distribution function. Okay, in distribution function all these values are cumulatively added, where it is the distribution function is bounded between 0 and 1, and here we get the 3 samples, 3 impulses. One is at x is equal to 0 with amplitude 0.5625, and at x is equal to 1 with amplitude 0.375, and with x is equal to 3 we get the amplitude 0.0625. Okay, how do you get these values? You do that one as some tutorial problem, because we can get these values by substituting here different values of n and k here with the p value 0.25 with something n c k into p power k 1 minus p whole power n minus k. Likewise we can get these 3 values here. Okay. In the next video I will cover Poisson random variable, uniform random variable, some other density function, followed by some problems also. Okay. If you like this video, please subscribe our channel and share it to your friends. Stay home, stay safe. Thank you.